Hi, it's Mr. T here. In this video, I'm going to go over how you might determine the concentration of chloride ions in a solution. In particular, I'm just going to explain how the titration of chloride ions with silver nitrate works and how we might calculate the unknown concentration of chloride ions, and also how we might standardize a silver nitrate solution. Okay, so the first thing I want to talk about is we use a silver nitrate solution to react with our chloride ions, but the silver nitrate solution we make up, and we might make this up in a lab, is actually can't be used as a primary standard solution. Now, primary standard solution is a solution that we can make up with a solid that is soluble in water, has a high molar mass, and is quite stable. But silver nitrate isn't stable when it's sitting in water over a time frame. So the silver nitrate is said to be a secondary standard. That is, we can use it to carry out titration with chloride ions, but we can't keep it for a prolonged period of time because it breaks down when it is in vicinity of ultraviolet light or sunlight or any type of light. So what that does is the sunlight will react with the silver, and it will produce the silver, react with the silver ions, and it will produce turn silver ions into silver metal. So what will happen is initially you'll start with a clear colorless solution of silver nitrate, and if you leave it in sunlight or it gets sunlight, it's put in somewhere where there is light, eventually over time you'll get little specks of silver produced in the solution. Now these specks of silver go on further to react with oxygen that might be in the water and water itself to produce brown silver oxide. Now, what's important here is that the original concentration of silver ions we thought we had, that we could make up a standard solution by measuring a known mass of solid into a volumetric flask, make it up to the line, but the initial concentration we work out would decrease over time because the amount of silver ions that are in the solution is less because they've either turned into silver metal or they've turned into silver oxide. Because of this, before you carry out a titration with silver nitrate with chloride, a solution that has chloride ions like a seawater solution or a solution from an estuary, you need to standardize this or work out the exact concentration of silver nitrate by reacting it with potassium chloride. Now, potassium chloride is a stable primary standard. That is, it's a solid with a relatively high molar mass that we can make up a solution of, that it won't break down any further if we have that standard. So we make a potassium chloride standard solution, and what a potassium chloride standard solution has in it is it has a specific amount of chlorides that's equal to the concentration of potassium chloride in the solution. So if I want to know the exact concentration of the silver nitrate solution I put it into a burette. I then put a sample of my standardized potassium chloride in the bottom, and I start to add, well, before I start, also to the potassium chloride in the bottom, I'm going to add some yellow chromate indicator to the flask. So this is 5 drops of chromate indicator. It's yellow, you'll get a faint yellow color. Then I'm going to start to titrate my silver nitrate. When I add my silver nitrate, what it's going to do is it's going to react with the chloride ions at the bottom. The silver ions will react with the chloride ions, and we'll get a silver chloride precipitate. That precipitate is a white cream color. So you'll kind of get this yellowy, creamy, white color from a mixture of the cream silver chloride precipitate and the yellow color that's present. So you'll get to recognize that color. You keep adding the silver nitrate, and then once you've added a certain amount, so we've added from about 22 up here down to 35 at the moment, we add a little bit more until we see the first change in color. Now we're looking for a peachy change in color. So the end point, at the end point, what will happen is all of the silver has reacted with the silver added has reacted with all of the chlorides. So when I add extra silver, there's no chlorides left, and now they'll go on and react with the chromates. And when they react with the chromates, they produce this peachy color for a start. So that's a wee bit of orange mixing with the yellow and the white precipitate. So we're going to get this orange precipitate starting to be created, and that's how we notice that we've added exactly the same amount of silver that we have chloride ions. Of course, we've added a few more particles, but if we stop as quick as we can after the color change, we can say it's approximately that the amount of silver and amount of chloride are exactly the same. We use this knowledge to calculate what the concentration now is of the silver nitrate by using the known concentration of the silver chloride and the amount of the volume of silver chloride and the volume of silver nitrate used. Let's look at how we do this. So now I've carried out 4 different titrations with this silver nitrate, and I've obtained the following results. My potassium chloride result was a concentration of 0.0221 moles per litre. Okay, so that was given to me. I took 10 mil aliquots of my potassium chloride solution and put them in the conical flask, and then I added my silver nitrate until I reached this peachy color. So here is one that has been completed. The first one I did was a rough titration. I didn't know exactly where it was going to stop, so notice here that the total volume, the titer that was added, is a wee bit bigger than the average of my 3 trials. My 3 trials are quite close to each other. They're within plus or minus 0.1 of 10.3, so they're within a range of 0.2 of each other, so they're concordant with each other. So what I'm going to do is I'm going to stop after 3 trials, because I have 3 trials that agree with each other in the volume that is added from the burette. I'm then going to take these 3 and average them to get the average volume that I added of silver nitrate to completely react with my chloride ions. So the average volume of silver ions to react with my chloride ions. That's 10.3 milliliters if I add these 3 numbers and divide by 3. Then I need to ensure that I change this number into liters for my calculation. And to do that, I take my number in milliliters and I divide by 1,000 milliliters per liter. And when we cancel off the units, we end up with 0.0103 liters. So now I've worked out the volume of silver ions I used. I know the volume of potassium chloride I used, because that's how much I pipetted or I transferred over, 10 mils. And I know the concentration of the chloride ions. So I know both the volume and the concentration of the chloride ions. So let's go through how we would actually calculate the concentration of silver nitrate when I know these 3 things. So as I just said, we know the volume of the silver ions, that's the average that we added from our burette, and that's 0.0103 liters. We know the volume of the chloride ions we added to the flask from our pipette, and that was 10 milliliters or 0.0100 liters. And we know the concentration of our primary standard potassium chloride, which is also the concentration of our chloride ions, which is 0.0211. So the first step I need to do is I need to calculate how many moles of chloride ions were there in the 10 mils of my potassium chloride that had a concentration of 0.0212. So I'm going to show in my first step what it is I'm actually calculating. So here I've written the moles of the chloride ions equals the concentration of the chloride ions times the volume of the chloride ions. And I've rearranged the equation of concentration equals moles over volume. So I start with the equation I'm using, and then I substitute my values into the equation. So I substitute the concentration into here and the volume into here, and I get this. So equation, substitution, and now I solve. And the answer to this is the moles of chloride ions is 2.21 times 10 to the negative 4 moles. Now, always one particular thing that we notice about the moles of particles in a solution, they're always quite small numbers, about times 10 to the negative 3 or times 10 to the negative 4 when we do this type of titration analysis. So we're going to then put this number into this table that I've produced here. So the table has concentration, volume, and moles as my columns, and silver ions and chloride ions as my rows. So this is the moles of the chloride ions. So I take the chloride ions, it's their moles, and I'm going to put the value in here, 2.12. Then we're going to say, okay, the moles of the Step 2 is we look at the equation for the reaction, that is every 1 silver reacts with 1 chloride. So we can now say the following: the moles of silver ions is equal to the moles of chloride ions, or we can say that the moles of silver ions equals 2.12 times 10 to the negative 4, because the moles of chloride is equal to the moles of silver. So I've now written down what is step 2 and carried out, substituted. I didn't really need to calculate here because these two are equal. Step 3, let me put this in here. So this is the moles. And now I'm going to do the third step and the final step, which is, can I find out the concentration of the silver ions? So we're going to use the equation in this original form, concentration equals moles over volume, but being specific, because I'm explaining what's happening here in my calculations, I'm saying the concentration of the silver ions equals the moles of the silver ions divided by the volume of the silver ions. And we're getting these from the second row of the table at the top here. So I've put the equation down. Okay, I'm now going to substitute. So I substitute 2.12 into the top and 0.013 to the bottom, and then I solve. So the concentration of silver ions equals 0.0215 moles per litre. And if you know that when you take silver nitrate and you place it into a solution, or it's aqueous in the solution, every 1 silver nitrate makes 1 silver ion and 1 nitrate ion. So 1 silver nitrate makes 1 silver ion. So if the concentration of silver ions is this, then the concentration of silver nitrate is the same, because they are 1-to-1 ratio. And that's how we work out the concentration of our silver nitrate secondary standard from a primary standard of potassium chloride. Before I go, I'll just go over how we might use this silver nitrate standard to calculate the concentration of chloride samples in an unknown water sample. Okay, so in this case, I've just calculated the concentration of my standard silver nitrate, and I'm going to use it on the same day. Okay, so it's not going to be a long time that I store the silver nitrate. So I know the concentration of the silver ions. I worked that out on the previous slide. And let's say here I've carried out my titrations, and my average volume for this sample of water that I had was, and the sample of water was 10 mils or 0.0100 litres. The average titer, or the average volume added from the burette, was 0.0123 litres. So the first step, we're going to do this the same way we worked out the chloride. When we go across a row, if we know two things, we work out the third. So step 1, let's work out the moles of the silver ions, because I know the concentration of the volume. And the moles of the silver ions equals the concentration of the silver ions times the volume. I put the equation down first. The second thing I do is I substitute the values from my table or from wherever I've recorded my results and put them into the equation. So 0.0215 times 0.0123. Then I solve. And my answer here solved is the moles of silver ions equals 2.64 times 10 to the negative 4. I place this value in my table. There it goes. The second step is I look at the equation for the reaction. In this case, remember, 1 silver ion reacts with 1 chloride ion to produce silver chloride solid. That's the solid we see at the bottom. That means this is a 1-to-1 ratio, so the moles of chloride is equal to the moles of silver. So whatever the moles of silver we just worked out in, we can say that the chloride is exactly the same. There it is. It's 2.64 times 10 to the negative 3 moles. I put that into my table. So now for the chloride row, I have two things: the volume of the chloride solution I added and the number of moles, or the amount of moles that are in it. So now I can work out for step 3, the concentration of the chloride ions equals the moles of the chloride ions divided by the volume of chloride ions. Substitute in my values and then solve. And here I've got the concentration of chloride ions equals 0.0264 moles per litre. This is in moles per litre. If you want to go on and calculate its concentration in grams per litre, you're going to have to multiply the chloride ion concentration by the molar mass. And that's how we work out the chloride concentration of an unknown water sample. I hope these calculations have been helpful, and look out for my other videos on titrations if you need any other help.